A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You know that feeling when you are staring at a blinking cursor on a black screen, and you realize that the last 3 hours of tweaking your kernel parameters just turned your expensive workstation into a very quiet, very dark space heater? It is that visceral cold sweat moment where you realize your last backup was 3-ish weeks ago, and it is currently sitting on a thumb drive you might have accidentally washed in your jeans yesterday.
It is the ultimate tech heartbreak, Korn. But the real tragedy isn't even losing the operating system itself. You can reinstall a base distribution in 15 minutes if you have a fast internet connection. The tragedy is the loss of the soul of the machine. All those tiny specific tweaks that you have spent years perfecting. The way your terminal padding is set to exactly 12 pixels. The custom key bindings for your window manager that are hard-coded into your muscle memory. The specific way your system handles scaling on a 4K monitor so your eyes don't bleed. That is what takes weeks to rebuild, and that is what usually breaks a person's spirit.
It really is like losing a diary rather than losing a notebook. A notebook is just paper. A diary is the history of your thoughts. And that is why today's prompt from Daniel is so timely. He is asking us to move past the era of the tedious manual backup and into the world of infrastructure as code for the personal desktop. He wants to reach that holy grail where if he fries the operating system, he doesn't restore from a drive. He just runs a playbook and watches his perfect environment rebuild itself from the cloud.
Herman Poppleberry here, and I have been waiting for someone to ask this because we are in a bit of a golden age for this specific workflow. For a long time, this kind of automation was reserved for sysadmins managing 10,000 servers in a data center. But with Linux desktop adoption hitting 5.03% in the United States this past June, the tools have finally matured for the rest of us. We are moving from treating our computers like pets to treating them like cattle, or maybe more accurately, like a reproducible recipe.
I like the recipe idea better. If I drop my cake on the floor, I don't try to tape the crumbs back together. I just bake a new one because I have the instructions written down. But before we get into the heavy lifting of how to do this, we have to talk about the obstacle. Why is this so hard for the average person? Most people think a backup is just dragging their documents folder to a cloud drive and calling it a day.
That is just the surface level corn. The real complexity lives in a hidden folder in your home directory called .config. That directory is the brain of your user experience. It contains the settings for every application you use, from your code editor to your browser to your music player. The problem is that these settings are often scattered, poorly documented, and sometimes stored in binary formats that are a nightmare to track in version control. If you want a reproducible system, you have to solve the dotfile problem first. You have to treat your configuration as code, not as a collection of random files you edited once 3 years ago and forgot about.
Right, because if I just install the programs, I get the factory settings, and nobody wants factory settings. That is like buying a house and never moving your furniture in. You are just living in a showroom. So, where do we start? Daniel mentioned Ansible and custom spins, but I feel like the conversation has to start with the most radical option on the table right now, which is NixOS.
It is the elephant in the room for a reason. NixOS treats the entire operating system as a solved equation. In a traditional system, you install a package, then you go into a folder like /etc and edit a config file. That creates a state that is hard to track. NixOS flips that. You write everything into a single declarative file. You tell the system what you want it to look like, and the Nix package manager realizes that state. If it isn't in the config file, it doesn't exist on the system. It is the ultimate infrastructure as code approach because the code is the system.
It sounds a bit like magic, but I've heard the learning curve is more like a learning cliff. I mean, you have to learn a whole new functional programming language just to change your wallpaper, don't you? That seems like a high price to pay for reproducibility.
It can feel that way initially, but the payoff is massive. Just look at what happened on March 3rd of this year. The NixOS Foundation announced official partnerships with Nova Custom and Framework. You can now buy laptops with NixOS pre-installed and fully supported. That is a huge shift in the landscape. It means the hardware drivers and the firmware are already handled in the declarative config. And for the user who wants reproducibility, there is a subtool called Home Manager. This is where the tiny customizations Daniel mentioned really live. You can define your GNOME extensions, your shell aliases, and even your individual application settings in that same declarative style.
So, if I have my Nix configuration file in a private Git repo, and I buy a new framework laptop, I just pull that file, run one command, and my entire world appears?
Every single bit of it, from the browser extensions to the SSH keys, assuming you are handling secrets correctly. That is the part that usually trips people up. You can't just put your private keys in a public Git repo unless you want to give the entire internet a key to your house.
I assume that is where something like Chezmoi comes in. I have been seeing that name pop up a lot lately. It is pronounced Chezmoi, right?
It is French for at my house. And while NixOS is a total commitment to a new way of life, Chezmoi is a tool that works on any distribution. It is a specialized .file manager. Instead of just symlinking files, it uses templates. This is crucial because your desktop might have a high-resolution screen, but your laptop might not. Chezmoi allows you to have one configuration that adapts to the hardware it is sitting on. It can detect your host name or your screen resolution and adjust your config files on the fly.
And it handles the secret stuff too, right? Because I'm not about to start typing my passwords into a YAML file just so I can put it on GitHub.
It integrates beautifully with password managers like 1Password. You can write a template that says, for this configuration file, go fetch this specific API key from my vault and inject it here. So your Git repo stays clean and safe, but your local machine gets all the sensitive data it needs during the deployment. It is a very elegant middle ground for people who aren't ready to jump into the NixOS deep end, but want that same feeling of a reproducible home directory. It solves the last mile of the configuration problem.
Okay, so we have the configuration covered. But what about the plumbing? Daniel mentioned Ansible. Now, I know you've been digging into the new Ansible 12 release from mid-March. Is that still a viable path for a single desktop user? Or is that like using a semi-truck to move a sandwich?
It is a big truck, but it is a very reliable one. The release of Ansible 12 and Core 2.19 introduced some significant templating changes. They are really pushing for better security and performance, which means if you have old playbooks from 2 or 3 years ago, they might need some validation before they work. But the beauty of Ansible is that it is agentless. You don't need to install a heavy daemon. You just write your tasks in YAML and run them. For a desktop user, it is like having a robot that follows your instructions perfectly every time.
What does that look like in practice for a desktop user? Give me a concrete example of how Ansible handles those tiny customizations Daniel is worried about.
Let's say you use GNOME. Usually you have to click through 5 menus to change your clock format to 24 hours. In an Ansible playbook, you use the dconf module. You write a task that targets the path.org.gnome.desktop.interface and sets the key clock format to 24H. When you run that playbook on a fresh install, Ansible checks the current setting. If it is already 24 hours, it does nothing. If it is not, it changes it. That is the concept of idempotency. You can run the playbook 1,000 times and the result is always the same perfect state. You can do this for your keyboard shortcuts, your theme, your power settings, everything.
I have to say, I love the idea of never having to click through a settings menu again. There is something deeply satisfying about watching a terminal scroll with green text and knowing that your favorite dark mode theme is being applied automatically. But what about the programs themselves? Installing 500 packages one by one via a playbook seems like it would take forever.
That is where we get into the debate between mutability and immutability. Traditional distros like Ubuntu are mutable. You start with a base and you keep piling things on top. But we are seeing a major shift toward atomic desktops. Think Fedora Silverblue or OpenSUSE Eon. These systems use a read-only root file system.
Read-only? Herman, how am I supposed to do anything if I can't write to the disk? That sounds like a very secure way to have a very useless computer.
You don't write to the system files directly. You layer packages on top of the base image using a tool like RPM Austri, or better yet, you use Flatpaks for your applications. This makes the system nearly unbreakable. If an update goes sideways, you don't have to spend all night in a TTY trying to fix broken dependencies. You just roll back to the previous deployment at boot time. It is like having a giant undo button for your entire operating system. When you combine an immutable base like Silverblue with a tool like Chezmoi for your dot files, you are about 90% of the way to Daniel's dream. You have a rock-solid foundation and a portable soul.
It sounds like the ultimate safety net. But Daniel also mentioned the idea of a custom Ubuntu spin. I remember back in the day, making a custom ISO was a nightmare of command line tools and crude environments. Has that gotten any easier, or is it still a dark art?
It has gotten much easier thanks to a tool called Cubic, or Custom Ubuntu ISO Creator. It is a GUI wizard that lets you open up an Ubuntu ISO, jump into a virtual environment, install your favorite apps, tweak the settings, add your playbooks, and then package it all back up into a new installer. If you have a fleet of machines, or you just find yourself reinstalling often, this is the baked-in approach. You carry your environment with you on a thumb drive.
But isn't the downside there that the ISO is a snapshot in time? The moment you bake it, the packages are starting to get old. By the time you actually need it, you are basically installing a museum piece.
That is exactly the trade-off. It is faster to install because everything is already there, but you are going to have a massive update waiting for you the second you boot up. Personally, I think the scripted approach with Ansible or the declarative approach with Nix is superior because it pulls the latest versions of everything in real time. It is more dynamic. You aren't just restoring a snapshot, you are rebuilding the latest version of your vision.
Speaking of dynamic, we have to talk about the controversy that literally just hit the headlines today, March 27th, this Node.js debate. Matteo Collina, who's a huge figure in that community, submitted a 19,000-line pull request that was largely generated by Claude Code. This is sparking a massive fight over what people are calling AI junk in core infrastructure.
It is a fascinating dilemma, and it relates directly to Daniel's goal. On one hand, the AI can write code and playbooks faster than any human. It can help you generate an entire Ansible role for your desktop in seconds. But the critics are saying this compromises long-term maintainability. If you didn't write the code, do you really understand how it works? When your automation fails at 3 in the morning because of a weird edge case, are you going to be able to debug 19,000 lines of AI-generated logic?
It feels like a double-edged sword for someone like Daniel. He could use an AI to build his perfect auto-install script, but if that script is full of hallucinated parameters or inefficient loops, he is just trading one kind of manual labor for another. I think there is a middle ground where you use the AI to explore the possibilities, but you have to be the one to sign off on every line of the playbook. You can't just copy-paste your way to a stable system, especially not when we are talking about the core of your productivity.
I agree, especially when you consider the complexity of modern Linux. We are seeing things like the system birth date controversy that popped up just a few days ago on March 24th. For those who missed it, there was a pull request to system to add an optional birth date field to user records. The idea was to help systems comply with new age verification laws.
And the Linux community reacted with its usual calm and measured restraint, I assume. No pitchforks or immediate forks of the project.
Not exactly. It led to several immediate forks of System Day and the creation of something called Ageless Linux. People are very protective of their systems, and they don't want government-mandated tracking baked into the init system. This is why having your own infrastructure as code is so important. If you decide tomorrow that you are done with a specific distro because of a policy change like this, your automation makes it trivial to jump ship. You aren't held hostage by your own customizations. You can take your Chezmoi templates and your Ansible playbooks and move to a different base in an afternoon.
That is a powerful point. Your operating system should be a disposable commodity, not a pet you have to nurse for 5 years. If you don't like the direction a project is going, you change one line in your config, run your script on a different base, and you are back in business by lunch. It gives the user the power back.
It turns the operating system into a utility, like electricity or water. You don't care about the pipes, you care about the water coming out of the faucet. For a power user, the water is the workflow, the programs, the shortcuts, the data. Everything else is just overhead. And with the tools we have now, we can finally manage that overhead with the same precision we use for server clusters.
So if we are going to give Daniel a roadmap here, let's break it down into actionable steps. Because we have covered a lot of ground, from Nix to Ansible to immutable distros. If he wants to start today, what is step 1?
Step 1 is the most important. Get your dot files into Git. Do not pass go, do not collect $200. Download Chezmoi, initialize it, and start adding your most important config files. Your bashrc, your chsconfig, your GPG settings. Once those are in a private repo, you have already secured the soul of your machine. Even if you don't automate the OS install yet, having your configs version controlled is a massive win.
And step 2, once the configs are safe, how does he handle the fry the OS part?
Step 2 is choosing a philosophy. If you want the absolute cutting edge of reproducibility and you are willing to learn a new way of thinking, go with NixOS. With the new framework partnerships, it is becoming much more viable for daily use. If you want to stay with a traditional distro like Ubuntu or Fedora, look at Ansible, but make sure you are looking at the Ansible 12 standards. The templating changes in Core 2.19 are real, and you don't want to build a house on a foundation that is already shifting. You need to validate your playbooks against the new security requirements.
And step 3 is the validation, right? You can't trust that your automation works until you have actually fried your system and restored it.
This is where people get lazy. They write the script, they feel good about themselves, and then 2 years later when their drive dies, they realize the script has a typo on line 42 or depends on a repository that no longer exists. You have to test your recovery. Use a virtual machine. Try to rebuild your entire environment from scratch in a VM once a month. If it works there, it will work when the stakes are high. It is about building confidence in your code.
I love the idea of a scheduled disaster. It is like a fire drill for your digital life. It takes the fear out of the whole process. Instead of thinking, oh no, I hope I don't break my system, you think, go ahead, break it. I have a script for that. It changes your entire relationship with your computer.
It is a very liberating way to live. It encourages experimentation. You are more likely to try a new desktop environment or a different kernel version when you know that the cost of failure is just 20 minutes of automated rebuilding. It turns the Linux desktop into a playground instead of a fragile museum piece. And as we see that market share climb toward 10% globally, these tools are only going to get better.
We should also mention the practicalities of data. Daniel mentioned storing all valuable data in the cloud. That is a big part of this. Your automation can rebuild your programs and your settings, but it can't rebuild your family photos or your work documents if they weren't backed up.
Right. The IOC approach handles the environment, but you still need a robust data strategy. Whether that is a simple rclone setup to an S3 bucket or a more integrated solution, the goal is to have zero unique data on the local drive. The drive should be nothing but a cache of the cloud. If the drive disappears, the data is still safe. This is the stateless ideal. Your machine has no state that isn't either in Git or in the cloud.
It is a complete inversion of how we used to think about computers. We used to think the computer was the thing that held our lives. Now, the computer is just the lens we use to look at our lives, which are stored safely elsewhere. And if the lens cracks, you just grab a new one and polish it with your scripts.
And that lens is getting more powerful. With Linux desktop market share climbing, we are seeing better hardware support and more polished tools. The fact that we are even talking about 5% market share is incredible. I remember when we were excited about 1%. Now, with 78.5% of developers using Linux, the pressure to make these automation tools consumer grade is higher than ever.
We have come a long way from the days of manually editing xorg.conf files just to get a mouse to work. But the complexity hasn't gone away, it has just moved to a higher level. Instead of fighting with drivers, we are fighting with state management and declarative configurations. It is a more intellectual challenge, but it is one that pays off in the long run.
It is a better fight to have. One is a chore, the other is engineering. And for someone like Daniel who works in tech communications and AI, this kind of engineering is exactly what makes the hobby fun. It is about building a system that is an extension of your mind rather than a hurdle you have to jump over every morning. It is about efficiency and peace of mind.
I think we have given him plenty to chew on. From the high-level philosophy of immutability to the nitty-gritty of dconf modules and Chezmoi templates. It is a big project, but the ROI on this kind of automation is massive. You spend 40 hours setting it up, and you save 400 hours over the next 5 years, not to mention the reduction in stress.
And you save yourself the gray hair that comes with a hard drive failure. That alone is worth the price of admission. Just remember to keep your playbook simple. Don't let the AI write 19,000 lines of code for you unless you are prepared to read every single one of them.
Before we wrap up, I want to go back to that system birth date thing for a second. It is a great example of why this matters. If you are on a system that implements a feature you find morally or technically objectionable, and you have your entire setup defined in a few text files, you can migrate to a fork like ageless Linux in the time it takes to drink a cup of coffee. That is true digital sovereignty. You are the one in control.
It really is. You own your configuration, so you own your experience. You are not a tenant in someone else's operating system. You are the architect of your own. Whether you use Nix, Ansible, or a custom cubic spin, the goal is the same: independence.
Well said, Herman. I think that is the perfect place to leave it. We have covered the tools, the trends, and the occasional drama of the open source world. It is a wild time to be a Linux user, but a very exciting one.
It has been a blast. There is always something new happening in this space, especially with the AI code debate heating up today. I suspect we will be talking about the long-term effects of AI-generated infrastructure for a long time to come. It is going to change how we think about writing our systems.
I am sure we will. If you want to dig deeper into some of the things we mentioned, check out episode 765, where we talked about engineering emergency SOPs. It dovetails perfectly with this idea of being ready for a system failure. And if you're struggling with voice input on your new automated setup, episode 1540 covers the Wayland Wall and how to scale that. It is a common pain point for people moving to modern automated desktops.
This has been My Weird Prompts. A huge thanks to our producer Hilbert Flumingtop for keeping the wheels on the bus and making sure we don't wander too far off into the weeds.
And a big thanks to Modal for providing the GPU credits that power this show and keep our AI logic flowing. We couldn't do this without that support.
If you found this helpful, or if you have managed to build the perfect auto-install script, let us know. We love hearing about the setups you all are building. Send us your playbooks, or at least the sanitized versions of them.
You can find us at myweirdprompts.com for the RSS feed and all the ways to subscribe. We are also on Spotify if you haven't followed us there yet. A quick review on your favorite podcast app really helps us reach more people who are tired of manual backups and ready to embrace the future of ERC.
Until next time, keep your .files version controlled and your root partition read only. It is the safest way to fly.
Goodbye, everyone.
See ya.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth